Hello everyone, welcome to lecture series on the topic non-parametric test. We all know about the parametric test. Just a bird's eye view of a parametric test is, it is the distribution of the parent population from which the samples have been drawn is assumed to be known. These tests were concerned with testing statistical hypotheses about the parameters of the population such as estimation of parameters, comparison of parameters, etc. Now we move to the non-parametric test. It is a statistical methods which do not require the form of the parent population or non-parametric test or distribution free methods. Here we did not know the basic population or distribution. Here no hypothesis is established regarding the parameters of the distribution and no assumption is made about the form of population. Certain assumptions associated with the non-parametric test are: first one is sample observations are independent, the variable under study is continuous, lower order moments like mean and variance exist. These three are the assumptions associated with non-parametric test. Now we move to the advantages of non-parametric test. That is, non-parametric tests are easily understood, it is simple and do not require any complicated sampling theory. Second one is, no assumption is made about the form of the parent population from the sampling is done. Next, non-parametric test can be applied when the data are classified on the basis of attributes such as nominal and ordinal data. Fourth one is, in case of socio-economic data where the data are not normally distributed, non-parametric test can be applied. Disadvantages of non-parametric test is, it is non-parametric tests are approximate test and in case if parametric test exist, they are more powerful than the non-parametric test. As the sample size increases, data manipulation required for non-parametric tests are sometimes tedious. Now we move on to the types of the non-parametric test. There are several types of non-parametric test. There are sign test, median test, Wilcoxon's sign rank test. So we are moved to the first non-parametric test, it is sign test. Here we consider a situation where it is desired to compare two things or materials where different pairs are observed under different conditions. For example, weights of any subjects. Here we are consider a person, weight of a person before and after some treatments. Here the differences di is equal to xi minus yi, I is equal to 1 to n have different variances and thus the paired t test becomes invalid, which would have otherwise been used unless there was obvious non-normality. So in such a case we use the sign test named. So since it is based on signs plus and minus of the deviation, di is equal to xi minus yi. Here no assumptions are made regarding the parent population. Here parent population is unknown. The only assumptions are measurements are lambda, the deviations di is equal to xi minus yi, I takes the value 1 to n can be expressed in terms of positive and negative sign. The second assumption is variables are continuous, they have a continuous distribution. Third assumption is di's are independent. The procedure for the sign test is as follows. Here we consider xi, yi, it is the pairwise observations, I takes the value 1 to n, be n paired sample observations drawn from two populations with the PDF f1 of x and f2 of y. We want to test the null hypothesis H0. f1 of x is equal to f2 of y, and the alternative hypothesis h1, f1 of x is not equal to f2 of y. Under the test statistics, we have to test h0. We consider di is equal to xi minus yi, I is equal to 1 to n when h0 is true and xi and yi constitute a random sample of size 2 from the same population. Since the probability that first of the two sample observation exceeds the second as the probability that the second exceeds the first, and since the probability of a tie is 0. H0 may be related as follows. Here H0 probability of x minus y is greater than 0 is equal to half, and H0 probability of x minus y less than 0, that is also equal to half. Let us define a condition or test statistics ui is equal to 1 if xi minus yi greater than 0, 0 if xi minus yi less than 0. If xi is equal to yi, the pairs xi yi is discarded or deleted under the hypothesis h0. ui is a Bernoulli variate with the probability p is equal to probability of xi minus yi greater than 0 is equal to half. Since ui's I takes the value 1 to n are independent. Here u is equal to sum of ui, I takes the value 1 to n. The total number of positive deviation is the binomial variate with the parameter n and p is equal to half. Let the number of positive deviations be k, then probability of u is less than or equal to k, that is equal to sum over r 0 to k ncr p power r q power n minus r. Here p is the probability, q is the 1 minus probability, that is equal to half to the power n sum of r 0 to k ncr, p is equal to half, q is equal to half under h0. Here the test procedure is to reject h0 if probability of u is less than or equal to k, that is less than or equal to alpha by 2. For large sample n greater than or equal to 30, we may regard u to be asymptotically normal with the expectation of u is equal to np. It is the mean of the Bernoulli binomial distribution because n is large sample, that is equal to n by 2. Here variance is equal to u minus e of u, root of variance of u minus n by 2 divided by root of n by 4, which follows normal 0, 1. Here the test procedure is rejected h0 if mod z is greater than z alpha by 2. So we will move the next test, median test, in the next video. Thank you.